Hello and welcome back to the lab. Today on the bench we have a donation from a viewer, a 7904A that is known bad, so we are going to have to spend some time getting it up and running again. And it's actually great to be back behind the camera again. I've sent some messages to some people and I've had some discussions on and offline, but I got wiped out. I don't know what it was that made me sick, but I got wiped out for about 4 weeks. So getting back into the swing of things. If I sound a little funny, I'm still recovering. I'm not 100% yet, but we're getting back into it. So we're going to take on this 7904. I'll give you guys as much information as I have, and then we'll see what the problems are. This one particularly comes with two 7826s and two 7B92As. And is a good example of the 500 megahertz frame from Tech. Very nice condition, especially considering its age. No options, but a very early serial number. Wow. Unit 507. So this is an extremely early serial number in the 7904s. My other 7904 is 31833. As opposed to 507. So what we know is it's blowing the main fuse, and I did confirm that, plugged it into power briefly, and power supply buzzes like it's supposed to. Overcurrent buzzing, you can hear it's struggling, and then the main fuse pops. So that's leading me to believe we have an issue pre-regulation, so it's probably going to be on the primary side of the power supply. So the next thing we're going to do before we do anything else, get the power supply out of here and take a look at what we're dealing with. All right, the only thing we did off camera was pull the plugins out to make servicing a bit easier. We'll pop the side panel off and give us our first view of the power supply. Fan's turning well. Put a little bit of oil on there, but not too much. All right, we have our... This is still scope board power supplies hiding back here. It looks in good shape. Other side of the case. It'll just come off. Well, no carnage yet, so we'll keep digging. Okay, to get the power supply out, which has been out before because we're missing a screw, this whole unit's going to pop out the back. These are usually posi drive screws. These are very stripped out posi drive screws. So it's been someone has been in here before. And there's the power supply. Okay, we'll do some quick resistance checking of the power supply rails, being sure to take into account polarity because we have some negative and positive supplies. So as soon as I find my ground pin, right here, let's see, so positive 15, 100 ohms, that's fine, plus 50. 3K, that's fine. Plus 5. 43 ohms, that's fine as well. Flipping polarity, we have negative 50. 1K, that looks healthy. Negative 15 is 200 ohms. So our power supply sanity check's okay. There's one tantrum cap right here. No, it's got some ohmage. Okay, so I'm not seeing anything scorched or blown up on the regulator board. I think our power supplies or our problem's going to be in this cage. So take some pictures, get some stuff out. Actually, these are the only two cables. No. Wait. Why is that missing? Interesting. what has gone on here. This isn't hooked up. So the plot thickens. That hooks up here. Can you guys see that? That will actually hook up in here. That's part of the high voltage supply for the tube. Interesting. Okay, well, I want to check some parts. Now I don't know if it was reinstallation error or if there's a fault in the supply. So now we have the detective hat needs to go on and figure out what's wrong. It's out. I'm going to clear this scope off the bench, but that was a pain in the butt, and I'll explain why here in a second. There are bolts on the far side, or on the underside of this rail. The power button actuator needs to come off, and there's 3 blind nuts you have to pull off on the back side of this. One actually had a bolt through. All right, here's our power supply out of the unit, and here is the pain in the butt. The 2 bolts that I had to take off were holding this switch assembly like this up against that rail. There's another bolted through fastener here, and another ground strap onto the back of the card cage. This was kind of a pain. They are switching both sides, so we're switching positive and negative on this. That's why there's 2 switches. And this just pushes down and actuates those micro switches. So I do want to check both micro switches just for continuity, make sure we actually are switching. If the neutral lead's getting an intermittent contact, it can make things do some funny things. But here we are. This is actually, as far as I'm aware, one of the first generation switching supplies that was used commercially. Start digging some of this stuff off. Let's start digging some of the sides off and see if we have some blown up parts under here. Switching transformers under here. Bulk storage caps are under here. This is just the regulator board. Pass elements are back here in the back, although we do have 1 rectifier there, which might be a problem. And I do believe some of the notes say we should beef the rectifier up on here. The initial rectifier is a little light for inrush current. So if that's the case, we will put a beefier rectifier in here for longevity's sake. Okay, with all the screws out, time to expose the dangerous parts. 4 more screws on the back, and these side panels will come off, which is what we'll do right now. And there we go. Pop the cover off on the high voltage section. This power supply has been off for a significantly long amount of time and was not fired up prior to this tear down. If you take the covers off the high voltage sections, take care. Obviously, it is the high voltage section. There are elevated voltages. Well, there we go. That's a good chunk of it. A little fuzzy. We'll clean that up. No problem. Nothing burnt, blown up, or destroyed yet. So that's a good sign. Here's our bulk filters. We'll check those for sure. I believe this is my rectifier under here. Here's more of switching control. Here is some of my rectification. I don't know if this is I think this is secondary rectification, actually. This is going to be the switching transistor. One of these 2 ICs is going to be controller. What else do we have here? Switching transformer is going to be on the bottom. Here's the legs for the switching transformer. Any of these capacitors could be suspect. We're going to want to investigate those fairly carefully, although I am not seeing anything blown up, destroyed, and exploded. But we do know, actually this is going to be the switching controller because it's a tech part. So this is the switching controller, and that's going to be the switching transistor. We know those are working because we're hearing the power supply buzz. This cap, that cap might be suspect. This cap might be suspect. Might be time for a recap on this. We'll see how it goes. Okay, well, I was doing a little bit of testing off camera on the bulk filters. I have them extracted. Now, they're a very odd mounting, which I have a sneaking suspicion is going to cause us some problems, is the capacitors screw into the frame here, protrude up through here. There's 2 layers of Kapton tape, one at the bottom, one at the top. It goes over the capacitors like this, and then they screw into the board. And that's kind of structural. It supports the board. This bolts into the frame, but it also bolts into the board. And it holds the side panel in. This is a really funky piece. Well, I was using the Atlas to test some caps. And .6 ESR, not too bad. 985 microfarads, which is a little high. These are 950, I think. Yeah, 950 by 200s. And so they usually read a little low. This is starting to drift a little high. And I checked the other one. The other one was reading about 1065, so very high. So this capacitor for sure has a leakage problem. This one might have a leakage problem. This one has a DC leakage problem. Now, I fired up the cap. We have the capacitor right here, and I had it hooked up to the source measure unit to see just kind of how bad the leakage was, things like that, because I was curious. Because it didn't read terribly high, but it did read high. And some weird stuff started happening. So I'm going to move you guys up to the SMU, and I'm going to hit go, and we'll go from there. Okay, so we're on the SMU. It is set up for a 100 millivolts, or 100 milliamp current and a 200 volt compliance voltage. We'll drop this down to 50 milliamps, given what happened, and we'll hit the go button. So we can start seeing it climb up. I'm hearing arc over. You can actually see the voltage come up and then fall out and then come up and then fall out and then come up and fall out. That cap is arcing over internally. I can hear it cracking in the lab. I don't want to torture the SMU, so I'm going to turn it off and watch how fast the voltage falls. So we have an internal fault in that capacitor, which is causing arc over at about 50 volts, well below its 200 volt rating. And so we have a bad component. So 950 microfarads, 200 working volts DC. Didn't even get to 100 volts. These do not go bad very often, but this one for sure is bad. So now I have an interesting challenge. Of how the heck do we replace that, especially with this weird mounting solution. So I'm going to have to see if we can find some capacitors, but we definitely have found at least one smoking gun with this power supply due to the fact that this is arcing over at 50 volts. It's never coming up to the DC voltage for the rectifier, so this is probably what's tripping my mains fuse. For sure, it's not helping. So next step would be source replacements for these, dealing with the mounting problem, and then going from there. I did check the diodes, just buzzed through. These diodes checked fine. Everything was good on that side of the switcher. So you guys can actually see hiding back there is the switching transformer in one of these things. So mains fuse saved the important parts, the switching controller, the transformer, all that other good stuff. We do have a dead bulk. And what we'll probably end up doing is working on this board some. There's a lot of these blue caps that we could swap out and get this thing all buttoned up for continued service. If I'm successful on these tend to be a little expensive. I'm expecting about 20, 30 bucks each for these caps, but if one's bad, that one's going to go too. I'm just not going to mess with it. If I got to order, we're going to do it right. Here's the measurement on the other one. Actually, ESR got way, way worse than it was before, but 1050. So no matter how I measure it, it was replaced as soon as I heard the snapping of it arcing over, but no matter how I measure it, it's toast. All right, we're getting back to this thing. So, what have we got? We have a pain in the butt. So, just to make sure we didn't have a problem, since we know we had a shorting issue, I popped the diode bridge off of the board. This is the main input rectifier, and we checked that with the DMM. So, in checking this bridge rectifier, we take the negative lead of the meter, hook it to the positive side of the rectifier, and then we go to the AC side, and we have diode, yes, flip it around, take the positive lead, hook it to the negative side of the rectifier, and diode, yes, and diode, yes. So our bridge rectifier is still healthy, and all is good. However, we have a fried up capacitor, which we'll talk about here in a moment. To say I tried many ideas of figuring out what to do with this capacitor is actually an understatement. So what we have is we have the roll from the capacitor. I was actually surprised how small this roll was, but these are only a 950 microfarad capacitor. But one of the things that's really interesting about this is the can is square onto the camera. The roll's shoved way over. We can also tell just by some discoloration here, which stops about here on the paper. It started to dry out, but then also there's some of the arcing damage right there. So cutting this can open actually told us quite a bit. This roll wasn't centered from the factory. There's tar at the bottom. And it started to dry out. A couple of these that I've popped open, they've just been chock full of electrolyte. This one didn't have any. So I'm not sure if it didn't seal or anything like that. This is the top that goes on there. And these caps have a really bizarre mounting solution on these. So you have the two terminals which feed through to these tabs which go into the roll. But then we have two mounting screws here which hold the capacitors in this configuration into this bracket. Now there's a insulating disc underneath the capacitors and actually over top of the capacitors to keep everything from shorting, or to keep the board from shorting out to everything. So we have an insulating layer on top of each can, and then they're screwed to this plastic frame, which is, or metal frame, sorry, which is an integral part of the power supply. It sits in this hole and also has places where external shielding bolts to it. So we have screw terminals here, board screws in right here, chassis screws in right here, so can't get rid of this frame. These caps also have a very bizarre lead spacing, 19.5 millimeters, if my measurement is decent. And not much stuff is made in that lead spacing. The snap caps are like 12, a couple of other things, so not much is made anymore in 19.5. The only thing I could do was I could source and find a replacement. So we have the replacement already put on the frame. We'll check it here real quick. Needs a bit of reforming, which we'll do now. We'll fire up a power supply and give it some voltage. Actually, we could give it 100 volts or so. It's a 200 volt cap. And let it see some voltage before we smack it with rectified DC out of the gate. So we'll put some voltage across this, current limited, and let it think for a bit. And then we'll also get moving on the putting the rectifier back in. So I can't find anything else wrong with the power supply, so I'm pretty sure that cap, which was shorting out, was what was taking out the fuse. So now that we have a replacement part, which is an exact replacement, nothing left to it, just but to put it back together. Let's see what we got. We'll actually throw it on the, I changed my mind. I think instead of a power supply, we're going to pop it on the IT28, let it sit for a little while, and just make sure it's going to be all right, because I can discharge that from the IT28 without messing around too much with a fully charged, decently sized capacitor at 200 volts. So I will set that up, let this reform for a bit while I put the bridge rectifier back, and we'll come back when the irons are hot. Well, I was putting the supply back together, and I got the bulks in, and everything was good, and I figured I'd check this cap out, which hides right here in the power supply. And this is supposed to be a 2600 microfarad capacitor, and I got 54 nanofarads at 0.8 k-ohm for ESR. So this cap is also out to lunch and is no longer a capacitor. So we got to get a replacement for this one too. All right, so we have our new capacitor installed. Actually, the snap was able to fit on the rings, and I was able to get some solder on there to hold it in. It's a 3363 volt to replace a 2635 volt. So infinitely better on the voltage, and a little bit more capacitance won't hurt the supply at all. So everything looks good. So now I've got to get all the covers put back on, get it in, and see if it'll light up the scope. All right, and we're back together, and we can call this maybe a power supply again. So at this point in time, we're ready to throw it back in the scope. One thing to note is I did take a look at the board. All these plugs, usually these are right in tech gear. Can't always be certain of this, but I haven't run into many of these that are incorrect and off the top of my head. If you take a look at one of the connectors, we'll zoom in. Pin 1 is indicated by this little arrow that's pointing to this pin. The connector has an opposing, or has a mating arrow, so you get the connector installed the correct way. This one's kind of really hard to. This one's really hard to see because it's buried. So before I put the back cover on, pin 1 is actually at the top of this back connector, and this is 108 volt peak to peak. This is the start of the high voltage supply. This goes up to the high voltage oscillator for the tube, and also for the and turns into ultimately the 27 kV supply for the CRT circuit, if I remember correctly. So I just marked pin 1, so when I put the connector in, I make sure I get it the correct way. This one's kind of a pain, because I got to hit the pins. If I can angle the camera correctly. There we go. I actually have to hit the connector on those pins down there. So this one's kind of a pain in the butt to plug in. But I'm going to hook everything back up, and we'll see if the frame's got some life. I'm not going to fire it up with plug-ins because I want the power supply to start. And if it does have another fault or something, I don't want to take the plug-ins out. Taking a look in the back side of the unit, we can see the two main plugs that connect to the power supply. This is that high voltage plug that goes into that connector that we were just talking about. You can see the hybrids on the back and all the signal routing for the, signal routing for the plug-ins. Verticals and horizontals will be over here, and power supply just sits in the back. Okay, we've done all the preliminary checking, making sure we've got all the connectors in the right way, in the right place. This is P82, we got P82, P83, P83. So that's all good to go. Everything's good. Meter bank up here, watching the negative 50 volt rail. Only one of the meters is hooked up. Just in case something goes completely sideways, I don't want the 6500 hooked up to it, since we're working with something that is fairly unknown, especially with some of the capacitors that needed to be replaced in this thing. I'm not really sure exactly what happened to this supply, but it's... I don't trust it at the moment. Okay, our power-up sequence is going to be as follows. We are going to spin this up on the variac, but I'm not going to spin this up all the way, and I'm not going to spin this up slow. This is a switching supply, and the way a variac works can actually do some damage to a switching supply. So I don't want to pull the voltage up slowly like I would do with a linear supply. What I want to do is I want to put about 20 volts into the front end just to start to get the rectification going, to get some capacitors going, make sure we don't have any shorts on the primary side. Fuse doesn't pop. If we see current skyrocket, obviously we have some bigger, deeper issues in the power supply, and we'll have to pull it out, tear it down again. If that works, we're going to have to give it full line voltage to get the switcher to start, see if the secondaries come up the way they're supposed to. If the secondaries come up the way they're supposed to, great, we have a fix. If they don't, then we'll have to go from there, figure out what's next. So I'm going to turn the supply on. Also making sure to keep my fingers away from everything that has line voltage on it. There's 110 everywhere. That switch has 110 on it. Like, it's going everywhere. But let's give it a little bit of power. If there's any excitement, you guys are going to know it when I do. Well, we're not drawing anything yet. We're up to about 47 volts. Nothing's actually even started. Do I not have the switch on? No, switch is on. Did the fuse go? There's no fuse. That's why we're not going to get any power. All right, what do I need for a fuse on this thing? 3.5 amp. Yep, that is on. Pushed in is on. So I need a 3.5 amp fuse. We have a 3 amp, which will be fine just for testing. I don't have full plug-ins on the frame. I will have to order a 3.5 amp. Looked through the lab, and it decided not to giveth. So we will figure that out on plan B. The one thing that kind of clued me off was I got up to about 90 volts and there was 0 current draw. So that's not going to do anything. All right, 11 milliamps at 6 volts, and then it fell out. So that was the cap starting to charge. 12 milliamps at 7, yeah. So it's drawing a little bit, charging up the bulks, and then falling out and going down to 0. So I think we're okay on the primary side. That's up to 20 volts, and it's fine. So let's, we got to go for broke and pop it into the wall. See what happens. That light fuse, if anything goes wrong, that 3 amp fuse is going to go away pretty quick. All right, here we go. Full line. Got fan spin, and I got 50 volts, negative 50 volts, which I should have. I don't hear the growling of the power supply anymore. And nothing popped. That's pretty good. At this rate, let me unplug this. Let it shut down again. I'm not going to hook the power switch back up yet because that's the most pain in the butt part. But I am going to bolt this in, flip it around. We'll plug it into the wall, monitor some power. And we'll see if we get a trace on the CRT. If we get a trace on the CRT, absolutely fantastic. All right, let's see if we get a trace. For plug-ins, we have a 7A16 and we have a 7B92. Both. This is a little light for this frame. This is spec'd for this frame, so nothing too major. We'll turn the power on. And we are drawing about 120 watts, and I have tube, which is fantastic. Do I have sweep? Yes, except my, yep, there it is. All right. So, we have trace. I have readout. Pots are a little crunchy. No graticle illumination. That's one thing we ought to check and see if we want to do with this particular scope is, do we want to LED mod it? So we do have a board option for this. I've done a couple of videos on it. So let me know in the comments if you think we should LED mod this, bring it back, or if I should fix the illumination. The illumination is a little strange in this one because actually the manual button's not, yeah, pulsed, gated. Yeah, something's wrong with the light circuit, which is fine. That's not a big deal. But let me know for LEDs if we think we ought to work on the lights. The pot on this plug-in is crispy as well. That's what all that jumping is. It's just the noise in the potentiometer. So really now what I need to do, which I will probably do tomorrow since it's getting a little late here in the lab, is I just need to let this burn for a while. So just to make sure it doesn't overheat or anything like that, leave it open like this before we put it all back together. Let it cook. Maybe show some waveforms. Doesn't even need to. We'll turn off all of the readouts so we don't torture the tube. Actually, the tube is in very, very nice shape. That's the 4th line of brightness, and I have a visible display on the tube. So like that, very good. Beam finder does work. Noisy switches, that's normal on these. But yeah, so just let the power supply do some burn-in testing, let it cook. And then I got to do all the normal stuff like hook the power button back up, a couple of things like that. And go from there. But we got got another 7904 for the lab. All right, here we are with the reassembly done. Power button works, and we're all hooked up. No pops, sparks, smoke, so that is excellent. Let's see if our tube comes on here in a second. Once the cathode warms up. There we go. So we got high voltage, we got CRT, everything is good. Gonna let this cook in the case for a while and just see how it goes. I don't expect there to be any problems at this point. The main faults with the power supply have been addressed, so just give it some burn-in testing, and then we're good to go. Well, it will need a full alignment after this, and then it's good to go, but at least we've finished up the repair. All right, well, burn-in testing was successful, and nothing else happened, no events, no smoke, none of the bad stuff, so this guy's ready for a calibration. Let me know in the comments below if you'd like to see another LED mod on one of these and where we should go from here. Obviously, I do need to calibrate the frame, get everything all set up and running so it's a finished scope again, but another 500 megahertz scope has been repaired. Thanks for stopping by the lab and taking a look at the power supply in this 7904A. If you like what you're seeing, hit the subscribe button and hang around. If you'd like some additional content, check out the Patreon page. They're running a little bit ahead of videos on YouTube right now, and the support keeps the lights on here in the lab and videos coming up to YouTube. With that, I will see everybody in the next video. As always, more's on the way. Bye for now.